information is communicated using this JSON file we have seen before. Let's see. So we first load that, and these are then the world trends. Yeah, because the world trend has this Yahoo Earth ID of 1, and this is then the trends that are now on Twitter for the whole world. And we have more information. So, for example, over here, so this is for Amsterdam. Yeah, so this is Amsterdam, and not only the name of the particular hashtag, but also the tweet volume. So in this case, yeah. So apparently there's no volume for a particular subject. But if you look up Sinterklaas, you know, then yeah, I'm not a Twitter expert, so. But apparently this is trending in Amsterdam. So anybody knows where to find the number? The number of tweets for this trend? Huh? Yeah, but so Sinterklaas, you know, that's trending. Yeah, so yesterday we had remembrance of the 100th year ago that the First World War ended. Aardenpoort, apparently, Tom. Now let's have a look at, I guess, the most famous Twitter of today, the real Donald Trump. So you can use this get user. Yeah. So this is then all kinds of information of this user. So we see Donald Trump name, print count. Seems a bit low, but you can see a huge number of followers, and then we can also read in his last tweets. Yeah, so over here, these should be the tweets, the last tweets of Trump. That's over here. Just returned from France. So let's have a look at let's check his Twitter account. But that's indeed the case. What is it? Donald. Hopefully.
No, he tweeted 24 seconds ago. So. He tweets so fast, so never in real time.
Okay, so now it should be here. Yeah, hopefully. Yeah. So you see that this over here?
Yeah.
So what we do is so these are all his tweets, and then this tweet has an attribute text, and there are a lot of more attributes. So let's have a look. Tweet cards, then you can also put tweets automatically using this Python, and you can also stream tweets. So if you just if you take this, set this into a loop, then of course you read the last tweets of Donald, and you can show them better. Yeah. So this is well, one example of how an API can be used for retrieving Twitter for tweets. Yeah. Okay, any questions? No? Then I suggest that we take a break, and after the break we continue with the levels.
Dankjewel.
Oh, dit ding is gewoon.
Ja, nee.
Is this vegan?
Yes. Milk.
Really?
Ja, bounce zo lekker van. Heel amper.
Yes. I will try half. I also ate cheese at that place. Can I
Ja, I know. Het is gewoon mijn hoofd, hè, waar je grap over zit te maken. Hey, hebben jullie het leuk met z'n tweeën daar? Ik heb je al splinter. Een beetje mensen pesten. Heb je op Twitch? Heel erg snel. You get it here. What? Not from India. Oh, zal ik even mee naar buiten komen?
Guys, got some Indian sweets here. Please help yourself.
Was the last week now?
Yeah.
Did you celebrate in Amsterdam?
Yeah, we did. There was a big.
Yeah. I heard the fireworks.
Your birthday?
No, it's Diwali festival.
Indian festival.
Indian festival. Last week.
I'm absolutely not cultured anyway, so I don't know this stuff.
It's
What type of celebration
in
is it?
India.
Oh, is it Christmas?
It's like a Christmas.
Yeah?
Biggest.
With the presents and stuff?
Yeah. Presents.
I've heard you do fireworks and all that kind of fire
Fireworks.
stuff.
Yeah.
I heard fireworks this week, and I was like,
That
I don't know what it. Yeah, okay. But it's and what was it called again?
Diwali.
the one.
Diwali.
Is it, I think, one day when they allow fireworks? Because, I mean, apart from the New Year.
Sorry, is it a holiday where it's allowed to have two?
Yeah, you can have.
No, I don't want to insult anyone.
Is it sweet? Sweet?
No.
No?
It's as sweet as I thought it was. Well, it is sweet. Nothing not completely devoid of sugar. I think they are very much enjoying what they're seeing. Just saying. Let's go outside.
Even better.
Waar was de HQ bro?
Ik heb lang
Almost
Yeah, well, we but if you can just
Also, I think Switzerland.
I'm here, man.
Oh, really?
No, I didn't see you. You're not there.
No, let's just communicate.
I'll walk over.
Okay, maybe just just put the blocks in the what are you and then you know if your idea is outside or you can join.
It can be a just customer.
It's even more
Sell more shit.
It's better. It's better than banking.
Yes.
Nothing.
It's a platform.
Really?
A platform. Like, it's not a platform. We got a really cool chart. How did the other one? Or did you do the cool one? Do the other one?
Oh, the other one.
Yeah.
With the green.
They already saw that.
Oh.
Yeah, it's so good.
I mean, for some it's a gain, some it's a gain. For some it's a job. It's all a matter of perspective. You know? The segment is person planning events, so you don't plan events is the bottom line.
When I was looking through the slides, you had to fill in and some didn't even make sense. Well, you had the one where you had to fill in the HQ. I was like, what? Yeah. No. That's the job HQ. Yeah. I don't remember HQ.
It's in the homework.
Yeah. That's like
If you go to maybe with your most important lines. No. Oh, yeah, this one didn't make sense to me either.
so I'm doing this one, so it's going to
Oh, okay. Yeah. Customer journey, I have no clue how we make the one of those.
Yeah.
Oh, yeah.
yeah, it's
Make it literally.
headquarters.
Oh.
Yeah, I know. I understand what HQ, but I mean, why would we ever fill this in for a person?
What's relevant? HQ.
This
Netherlands.
there's literally no there's literally no purpose to this slide.
It's single-sided, so we can't do it.
Yeah.
We're multi-sided.
Just delete it.
Just go one page further. Oh, no,
I had to check both parts. I was like, what the
you were literally in the classroom.
I was listening.
You were sitting next
I
to
was
the
at the
guy.
front.
Yeah,
That's where you don't.
Yeah, you were watching a video or something. It was really trippy. Yeah, well, I could see him, and I was like,
but you have
No,
it's actually
leap of faith.
Yeah,
I put a couple in there. And I looked up how to do this one.
Apparently, we also need priorities here.
but it's
Yeah, but a lot of stuff was later.
yeah, this is
Tell me what you said.
What don't you get?
yeah, but the problem is those examples they are built for local let's say no installation.
Yeah.
So then it makes it a little bit
Yeah.
hard.
Yeah.
But actually you can do pretty cool things. So if I have this
But I mean, then it's okay because we got like a 7.7, I think. It was quite soft. Yeah. So it was like we
Or
could,
just trying to
Yeah,
help,
I-
so
I-
just trying to kind of focus the directors tangible example rather than too wide. But it's like, this type one.
Yeah, you also.
Oh, that's a copy paste.
We have to say. Like what? How does a tagline tell you what it is?
that was the only thing he said.
The point of a tagline is that it's a hook, and then you're like curious what it is.
No, it shouldn't be. It should be focused on your product.
So how's Beyond Petroleum BP then? Like how-
Beyond petroleum, it's petroleum. So you know, there you go.
Yeah.
But it's beyond.
It's beyond platform.
Again, put that. That would have A plus actually.
Platform Beyond.
That's a spark.
Is the best with him a bit.
Maybe a debate, right?
Well, I actually read it as spark.
So the purples are for both sides,
Framework uses
the oranges are for more.
What is this?
The blues are more for the.
Okay, but I mean, what's in it?
Because retention has nothing to do with the cashew.
Okay.
Getting the best deal. It's the reverse, you know, like.
No, it's not sweet at all.
It's not.
Well,
I like it. I mean,
No,
From
the
Dutch
the
then.
oranges are
Yeah.
on the customer side. This is only the business side. The purples are only.
Yeah, a lot of calories for sure.
Oh.
It's cashew.
for brain.
nice. Yeah, very nice. It's a bit more.
At first,
Visit
I had
company
one team
Buy
that
a book, actually, a bar,
Baskets
football game.
That's what creating here, like with you guys, no fasting in this. Maybe someone.
What?
Database.
I have no clue what it is.
I know what it is. It's about the
changes here, so I,
about the fight between good and evil.
and then it calculates.
Okay.
it, so it's really
I will into that.
Big
Yeah.
So,
the guy south of the forest.
Yeah. Yeah.
he was evil.
Alleen ja, dus die cultuur die
About the jealous wife.
That's our story from. Yeah, it's for the day that Dutch. Last month there was one more festival.
Oh.
Then,
We had a celebration at work, so we showed the video.
okay, so burning of like 10 again.
Yeah, you can say.
Yeah, that one.
That's last year, that's different.
And there was a Muslim.
Yeah. Yeah, the wife was kidnapped by this bad guy.
Yeah.
Took 3 months.
I have something. You have a map?
Yes.
And of course, this part was the weak one.
You can
Really into this.
Yeah,
I watched the format.
on this.
Ramen is the big. But it's
But going back to this, Mervin has a point. Do we respond back to the guys?
for the first one.
Yeah,
I think we'll just carry on.
We only need to do the new
I
stuff,
think
right?
at the end, we're just meant to have this. Right?
Maybe finally we will consolidate.
accounts, dat geven dus de
As well. You told the track line, I started the whole idea where you mentioned your wife does.
Take this and this
So I
starts.
use that.
Nou, dat doe je.
Okay. Very niche, target. And he's like, has no other stuff.
I put it there. Oh, nice.
And then you see the. Yeah, there's a lot.
No, but our platform,
It's not correct.
it's beyond.
Mother of all plants.
You don't need another platform after us.
Beyond everything.
Beyond life.
The examples nowadays.
How do we say it? The platform it
What is
brings,
it?
it brings
Did you read the
Local
area code?
local.
And no, that's what we have actually.
we're sucking up.
This was your elevator system, right? You're doing them, right? You get a negative.
World class
You have to include
En ik had het uitgerekend.
Ja, It's literally
Completely. This is on top of that.
you have your platform and you have our platform. We don't do extracts. We don't
You started? You're wrapping up right now. Yeah, wrapping up. End of this month. As we start looking for
We bought it up for 10 years. We need an M&A expert. We need one that's
you guys. Let's see what you can join. But I'm gonna pay you last. We have Friday,
First March is one of the experts. There we go. We're gonna yes. Write down your details.
So you need to implement the cloud.
Why not? Sorry, what? Yeah. I like the idea so much. I can make you.
What is that?
What is it made of?
Cashew. It's milk and cashew. Those two, mainly those. When did you get these?
That's what you eat at the during the Bali.
Sweet delicacy and cashew.
Is there really milk inside? Maybe there's no. There's no milk.
We continue with chapter 3.
It's vegan. It says sugar.
Cashew nuts.
So this is about explanatory data analysis.
Okay, then you can have it.
EDA.
Sugar, potassium.
So for sure, EDA. And the idea behind EDA is that we get some insight in the data without any prior knowledge. So we just let the data speak for itself and see whether we can identify, let's say, relationships between the variables, and hopefully with the variable we want to predict. And we do this in a, let's say, with a clear mind, with an open mind. Yeah. So sometimes an analyst may have an a priori hypothesis. So this is not with an open mind. So this is that you already have some idea what you would like to test. So this is really hypothesis testing, and this is something different than this explanatory data analysis. So the example for hypothesis testing could be, for example, there's a fee restructuring. Yeah, so the fee structure has changed. Has this led to, in this case, a reduction in the market share? Yeah, so suppose that the market share we divided by pi. So let's say the hypothesis that pi is equal to some particular constant. So this could be pi 0. And then the alternative is that pi and market share has decreased. So that it's gone down. So it's smaller than this pi 0. Yeah. And then this pi, that's just the market share, and the market share can be estimated by the market fraction. Yeah, so you just divide, let's say, your customers with the total customers in, for example, a country. Now, and then, so this is just like an average, but it's scaled with respect to all the customers. So in that sense, it's a fraction. It's between 0 and 1. Yeah? And then you can just test this hypothesis using, for example, the t-test. So that's hypothesis testing. Yeah? And actually, you already know the theory because that's the theory we started off with in statistics. Yeah? And also, let's say, the multivariate approach that's then dealt with in econometrics. And so suppose that you want to correct for other features, then you could use, for example, a regression analysis. Yeah? So then this is the market structure is your variable of interest, and then you have some control variables. Now, not always we have some beforehand knowledge, so a priori knowledge about what we are after, or what is exactly the variable of interest. And then we can use this exploratory data analysis, and this can be useful just to get to know the data, to examine whether there are important relationships between attributes. So what's the term for interrelationships in econometrics? Yeah, so multi-collinearity, to see whether there's multi-collinearity. And if there's severe multi-collinearity, then you have to make a choice which attribute you want to include or not. Yeah? Or you could do something like principal component analysis, which is also one of the topics. Then identifying interesting subsets. So we will see that we zoom into a particular subset of the data in which something interesting is going on, and perhaps you might develop an idea which predictors will be useful to include in your model. Yeah, so let's have a look. This is the data, and the data you are familiar with because it's the same type of data as in the first assignment. Yeah, so the idea is as follows. We are interested in the probability that people churn, and this churning probability is the probability that the customer will switch to another telecom provider. Yeah, so for you, that's harmful because then the customer prefers another telecom provider to you. So this is the variable that we want to predict. So in this case, it's all false. So these are non-churns. And we have some characteristics, some attributes or predictors. So we have the state, the account length, so that's the days for which the account is active. We have the area code. We have a phone number in 7 digits. Then we have several characteristics of the contract, the telephone contract. So in this case, you could either have subscribed to an international plan. So if you want to phone, let's say, outside the US. We also have a voicemail plan, apparently. So this is quite old data, where you had to pay additional for the voicemail option. Then we have day minutes. So this is the minutes that you actually phone. This is the number of calls, and this is the day charge. So you will see that there is a close connection between the day charge, because the day charge is just, let's say, a fixed fee plus a variable fee, which depends on the minutes that you phone. So this is the information we have for the day calls. We also have this information for the evening calls and also for the night calls. We also have, and also for the international calls. Okay. So the insights, there are 2 flag variables. So there are these 2 variables, whether or not you have subscribed to the international plan or whether you have subscribed to the voicemail plan. Most variables are continuous, and the response variable we want to predict. That's a flag variable, so we only have 2 values. The customer either stays, then it doesn't churn, or it goes away, then churn is true. Let's have a look. So the first thing we like to do is to summarize the data. And in this case, the summarizing of the data is looking at the histogram over here. Histogram. In this case, the computer is also telling us something about the time. So in this case, we have 2 flag variables. These are whether you are subscribed to the international plan or the voicemail plan. And the other one, a range, that's just continuous. And we have a set variable, that's a nominal variable. And so in this case, this is the area code. So there are only 3 area codes, and this is the number of states. And what we also see is something unusual over here. So the voicemail messages, there's a huge spike over here at 0. This is of course understandable because well, if you don't subscribe to this voicemail plan, then by definition, the number of voicemail messages will be 0. Yeah. So we see that not everybody has this voicemail plan, and therefore we have this spike of the 0. Judging the shape of histograms, we see that these histograms seem to be, let's say, normal shape, so they are kind of symmetric. But we see over here 2 other variables which are not so symmetric. Yeah. So for example, over here, this is the number of calls to the customer service, and we see that this is really skewed to the right. So this is positively skewed. And we also see the number of international calls, that's also skewed to the right. Yeah. So most of the variables, continuous variables, seem to be normal. So not too many outliers, but over here, these 2 are really skewed. Now, what are we interested in? We are interested in probability that the customer churns and how many customers do churn in this data set, and that's around 50-45%. So 50 or 14.5%. That's in this case the marginal probability. Yeah, so this is without reference to any other information. If you don't have any information about the customer and you would randomly select one customer, then the probability that you will churn is around 14.5%. Now, the goal is to develop a model in which we can do some profiling. So in the sense, we can identify customers with particular characteristics which are more likely to churn. Now, let's have a look. So we have these two plans. So we have this international plan and voicemail plan. Let's have a look at the first variable we are going to investigate, and that's whether people have subscribed to an international plan. Now, so over here, we see the percentage of people that have subscribed to an international plan. So that's around 10%, and 80% doesn't have subscribed to an international plan. Now, what we see over here are two colors. The red colors, the red colored areas, they refer to people who have churned, and the blue colored areas are the customers that didn't churn, so didn't leave. Now, what are we interested in? We are interested, of course, now in the proportion, the ratio between the people who stay versus the people who leave. Yeah, so there's a ratio. In this case, we see that a small number of people actually churn if they have subscribed to this international plan. We also see over here, this is even smaller, but we have to compare it to the area of the bar. Yeah, so over here, this red area, of course, is smaller than that red area, but the whole area of the bar over here is much larger than over there. Yeah, so this seems to indicate that almost half of the customers who have subscribed to an international plan has churned. Yeah? Now, how could we correct for the area of the bar? Well, we could correct for the area of the bar by, let's say, normalizing the area of the bars to the same area. So that's done over here. This is called the normalized bar graph with churn overlay. Yeah. So here it's clearly that people who did subscribe to this international plan have churned a lot more than the people who didn't subscribe to the international plan, because this red area is much larger than that red area. Yeah? Everybody sees it? Yeah, so it's the ratio between the red area versus the total area, which is important. And in this case, the two areas are not the same, so we cannot compare these two red areas, but over here they are the same, and therefore we can easily compare the red areas. And the conclusion in this case would be that people who have subscribed to the international plan somehow have larger probability to churn, to go away. Because apparently, this company is not attractive for people who have subscribed to this international plan. That's the conclusion. So we already have some characteristic some profiling, which will be in the final model, and that's whether or not the customer has subscribed to this international plan. Now, we don't have any quantitative information about this relationship because this is just quantitative. We compare just areas. So what we can do is we can make this more quantitative by looking at a table. So this is a table with numbers. Yeah. So in this case, we see that the total number of customers is 3,333, and almost somewhat more than 3,000 have subscribed, did subscribe to this international plan, and somewhat more than 300 did subscribe to this international plan. Now, what we can do is we can normalize this table. So this is a bivariate frequency table. We can normalize this with respect to the columns or with respect to the rows. Okay. Now, over here, this is the contingency table, and the contingency table with the column percentages. Yeah, that's important because this is the column percentages. And what we see over here is that apparently of the people who did subscribe to the international plan, the churn probability is 42%. And of the people who didn't subscribe to the international plan, the churn probability is only 11.5%. So this is more than 3 times higher. So customers that have subscribed to the international plan are 3.5 times more likely to churn than people who didn't subscribe to the international plan. Yeah? Now, so how is this calculated? This probability over here, that's this count, 173 divided by the column total. So that's 3 to 3. This over here can be interpreted as bivariate frequency. Yeah. So this is the number. This is the number of churners that are not subscribed to the international plan. So the international plan is did subscribe. So that's yes. And we divide by the total number of international plan subscribers. Yeah. Now this we can interpret as what kind of probability? So this is a bivariate and this is a marginal probability, and the ratio of a bivariate and a marginal probability can be interpreted as a conditional probability. Yeah? So this can be interpreted as the probability that someone is churning given that the international plan was activated. Yeah? Sorry.
Bless you.
So this is a conditional probability. It's probability of churning, given that we know that this customer did subscribe to the international plan. So this is then a conditional probability that it's churned with the international plan, and this is for probability that the customer churned without the international plan. And this is exactly what we are after in a regression model. Yeah, so this is the variable we want to predict. And then over here, we have the characteristic, the information of the customer observation. Now we can also do it the other way around. We can also divide by the row totals. So that's given over here. Oh, so this is still the column totals. So this is then 2 pie charts. And indeed we see that this area, this is the area of churners, is almost it's more than 3 times larger than this area. So this is this is 10%, this is around 40%. Now we can also do the same analysis, but now we standardize by the row totals. Yeah, and what we can do is we can, for example, compare these 2 numbers. Yeah, so for example, this over here, this 28 divided, no, this 137 divided by 483. Yeah, so this again is the number of people who churn. Churn is given that the international plan was activated, and now we divide by
Total churners.
Yeah, so this is the number of churners. So this can be interpreted as, again, a condition of probability. But now, indeed, with the 2 events reversed. Yeah, so this is the probability that someone has subscribed to the international plan, which yes, given that someone is churning. And so we see that this conditional probability that someone has subscribed to the international plan for the churners is 28.4%, and this can be compared to this 6.5%.
So this is condition.
Again, we see that this is much higher, but we are not really interested in this conditional probability. We are interested in predicting the churning rate. Yeah? So this is something that you should keep in mind, that you have to normalize with respect to the correct column or row totals. It depends upon whether churning is over here as rows, or
No, this is just a
you can also have the
column
contingency table, of course, with the churn
42
in the columns.
The actual probability is 28.36.
Now this is the same information, but now given for the conditional probability that someone is subscribing to this international plan. This is for the churners. This is for the non-churners. Yeah, so the conclusion in this case would be to investigate what it is that people that subscribe to this international plan, why they are leaving. Now, the same can be done for the voice mail plan. So in this case, the conclusion is somewhat different. So, which group churns the most? People who have a voicemail plan or without? Yeah, without. So in this case, it's the other way around. If you have a subscription to the voicemail plan, the probability of churn is higher. Yeah. So in this case, one conclusion could be that perhaps customers are more loyal if they have access to this voicemail Let's see. So in this case, we are indeed preparing the column totals. So let's see. So we see that if you don't have a subscription to this voicemail plan, the probability to churn is somewhat higher than if you are subscribed to this voicemail plan. But we see that the difference is much smaller. So if you know whether someone has subscribed to this international plan, that will be more powerful in a predictive sense than if you know that someone has a subscription or doesn't subscribe to this voicemail plan. Now, what we could do is we could zoom in to a particular group. So the idea is that we have now two characteristics. We have people who either have access to this international plan or don't have this international plan. So let's have a look. The columns are international plan, and in this case, the voicemail plan is no. So over here we have the voicemail plan. So that's yes or no. So in this case, it's no. This is yes. And this is here we have the international plan. And this is also the columns are the international plan. So that's the international plan.
You're only considering voicemail plan no.
And the voice. So this is a yes, and this is no, and this is no, and this is yes. Yeah. So in this case, we are zooming in until these two groups. Yeah. So we already know that the voicemail plan is no, and then we can distinguish between whether they have subscription to the international plan. Yeah, so this is something different than before. So this is based on a conditional probability, where we not have conditions on one characteristic, but now two characteristics. Yeah, so this international plan and the voicemail plan. In this table, we are only considering the people who didn't subscribe to the voicemail plan, and then we can see these churn rates. So that's over here. Is still. Let's have a look. So there are 14 people, 40% of churners for the people with no international plan. So this is 40%. And this is 44%. Then we consider the next segment. So these are all the customers who did subscribe to the voicemail plan, and then we're looking into whether they have an international plan or not. And in this case, let's see, the churn rate is 5%. With only the voicemail plan, so this is 5%, and this is equal to 39%. Yeah, so again, we see an increase in the churning rates if people have subscribed to this international plan. Yeah, so you could zoom in more and more and more, but that's actually what you do if you do regression. If you remember, we had this example in this statistics course about the student-teacher ratio. Then we had the student-teacher ratio, which we divided into what is it? The socio-economic class. We had something like whether families are they can be subsidized lunch boxes, etc. Yeah. So we are also zoomed in into the class size, whether it's large or small, and then another variable. Yeah. So over here, this is the same idea that you could zoom in into one particular group of customers, and of course, this is what you do if you introduce control variables in a regression model. Now, in this case, you don't use a regression model, but you will use the variable you want to predict is not continuous, but discrete. Yeah, classification. So it's a logic model. Yeah. So in this case, you would use a logic model to estimate the churn probability, and you can, as control variables, you could, for example, include international plan and functional plan. Yeah. Let's see. So this is exploring numbering variables. So these are all the variables that are continuous. So now we want to see how can we detect relationships between, let's say, a numerical variable, so not a binary, but a variable that takes more than two values, with the probability of churning. And the idea is exactly the same. So over here, now we have an histogram. So instead of having only 2 bars, we now have more than 2 bars. And each bar, we can separate between the churners, the red areas, and the non-churners, the blue areas. So these are the histograms, overlaid histograms with the churning status. And again, if we really want to compare whether there's a relationship, what should we do? We should normalize it. And this is then the normalized histogram with the customer service calls. So what is the main message to take away from this normalized histogram? Yeah. So the larger the number of customer service calls, the larger the churning probability, and there seems to be a jump over here. Yeah. So you could say if a customer calls the service desk more than 3 times, then the probability that he or she will churn is almost doubled. Yeah? And that's of course understandable, because usually you only call the help desk if you have trouble. So this is a very convenient way to investigate a relationship between a variable which can take more than 2 values with the variable that only can take 2 values. Now, what we see over here is here. This bar has a churning probability of 100%. So all these customers will go away. So is this something which is interesting for the telephone company? Exactly. Yeah. So in this case, there are only, let's say, 2 customers which make 9 calls to the services. Yeah. So that's why you should always also include a non-normalized histogram, because we can see over here that the number and the absolute frequency with, let's say, 9 calls to the service desk is really, really low. Yeah, so that's something that you always should keep in mind. So churn rate is 100%, but it's only 2 customers. So these are 2 other normalized histograms. Here we have the day minutes, and here we have the evening minutes. Now, if we look at the day minutes, is there a clear relationship with churn rate? And what would be the relationship?
More people call, the more
Yeah.
the chances they will choose another.
Well, first it seems to increase a little bit, but then there's a sharp increase. Yeah. So there is definitely a relationship with the minutes, the day minutes that the customer calls. But is this relationship linear? Not really. Okay. So if there would be a linear relationship, then we would expect something like this. But it seems to be like an inverted V-shape. So what we will see later on is that what we can do is we can, let's say, take 3 classes with low, medium, and high, and have separate effects for these 3 classes. So make the relationship, in a sense, non-linear. But for the evening minutes, that doesn't seem to be a very significant relationship. Over here, it's somewhat higher, but again, this will only relate to very few customers, probably. We don't see the non-normalized versions, but the relationship with the day minutes is more pronounced than for the evening minutes. So apparently there are not many other numerical attributes with significant relationship with the churning rate. But should we therefore just forget about these other characteristics? And the idea is no, that data speaks for itself. Yeah? So if the number of features, the number of input variables, the number of attributes, it's not too large with respect to the sample size, you should always include as much predictors as possible, because it could be that our interaction effects, such that there is no relationship if we look over here in just one dimension, but if we consider 2 dimensions, there could be something like a relationship. So that's over here. So in this case, we see the number of day minutes, and this is the customer service calls. And what we clearly see is that in this region, there are predominantly red dots. So red dots are the people who churn away. So the churning mobility is very, very high for people with low value of the day minutes, but a high value of the customer service calls. So that's even more pronounced than if we only consider the number of service calls. That's over here. So that there is this interaction between these 2 variables, which really separates these customers from the other customers. This is also another subset that's over here. Let's have a look. This is the this is the day minutes, and this is the evening minutes. So here are the evening minutes, and here are the day minutes. What we see is that if the day and the evening minutes are really, really high. So these are really frequent callers. They end in the evening. Then they also have a larger volume of insurance. Yeah, so in this case, churn probability is indeed above 40%. So this is a way to identify, let's say, interaction effects between two variables. Now, you can also, of course, use this exploratory data analysis to uncover some strange things in the data. As you might have noticed, there were only 3 area codes, and this is great. And all these area codes, they belong to the California state. Yeah, so either this is a telecom provider which only sells in California, or there's some filter which was active when this data set was generated, or this area code is just wrong. Now, let's have a look at how the area codes are distributed over the states. So these are 3 area codes which actually only belong to California, but we have more than 50 states. Now, how are they distributed? Are they evenly distributed? And the answer is, well, you can actually test this using a statistical test. This is the so-called test of independence. So we have 2 nominal variables. So over here we have the state, which is a nominal variable, so there's no order, and it's definitely not continuous. And over here we have the area codes, which is also unordered. And so we have 2 nominal variables, and we want to see whether they are independent from each other. Well, what does it mean if they are independent? If 2 events are independent, A and B, then the probability of A and B is equal to, yeah. So in general, we have probability A times the conditional probability of B given A. But if we have independence, then this reduces to the probability of A times the probability of B. Because if A and B are independent, then they have no relationship, and therefore the probability that B occurs given that A has occurred doesn't give additional information, and this is just the same as the marginal probability. Now over here we have a product of 2 marginal probabilities, and these marginal probabilities we can find in the margins of the frequency table. Yeah. So what we can do is we can have over here the marginal probabilities for the area codes. We can over here calculate the marginal probabilities for the state codes, and then it's just the expected, the number of people that we expect. So in this case, how many people do we expect for code 408, and in the state AK? Well, it's this probability, so it's the total number of code 408 divided by n, sample size. Under independence, we have the marginal probability of the state, per state. So that's just, this is 40 plus 24 plus 20 plus 40 divided by n. Yeah. And then we have to multiply it by n. Yeah, because so this is the margin probability that someone is from this area code 408. This is the margin probability that someone is from this state OK. And then how many customers do we have in total? That's equal to n. Yeah. So then you see that 1 n cancels. So the expected frequency is just the row total times the column total divided by the grand total. Yeah, just like over here. So this is the first column total. This is the first row total, and we divide by n. So this is what we expect under independence. Yeah, if they are independent. So what would be a test statistic? Well, of course, the difference between what we observe in practice and what we expect under independence. So in this case, it's the difference between what we observe and minus what we expect. Yeah, so this is the difference. Now, sometimes the observed frequency is a bit higher, sometimes the observed frequency is a bit lower. So this term over here could be positive or negative. Therefore, we square it to get something which is always positive. And then we want to normalize it. Yeah, because a difference of 1, if the difference is 1, and we expect 10, this is a quite large deviance, because this is 10%. But if we have 1 and we expect 1,000, then this is a very small deviance. Yeah. So this is a deviance of 1/10 of a percent. This is a deviance of 10%. So therefore, we also want to normalize with the expected number. Now, you can sum this, and then you get something which is chi-square distributed. And this chi-square distribution has one parameter, that's the degrees of freedom. And the degrees of freedom is equal to the number of rows minus 1 times the number of columns times 1. Well, why is the number of columns and the number of rows minus 1? Now, suppose that I have over here given the column totals. So over here, so these are the column totals, the row totals, and now I reveal a number over here, let's say 20. How many degrees of freedom do I have? Well, none, because over here the column total should be 100, so this should be 80. So we infer that this should be 80. Over here, we infer that here we should have 5. And if this is 5, then this should be 45. Let's see. Yeah, of course, this should be the same total. Yeah. So this should be the same total. So this is, let's see. So this is 100, and then we could have 75, 75. Yeah. So then this should be 55. That's also not possible. So this should be lower, and the other one should be higher. 30.
4 seconds.
And 100. So this should be 10, and this should be 40. Yeah. So now it's. Yeah. So we see that if I give you the column and row totals and only one number, there are no freedoms, degrees of freedom left. Yeah. In this case, this is a 2 by 2 case, and the degrees of freedom is equal to 1. In this case, the number of columns is equal to 3, so that leads to 2 degrees of freedom, and suppose that we have 51 states, then we have 51 rows, so then the degrees of freedom for the rows is equal to 50. So it's 50 times 2, that's 100 degrees of freedom. And that's actually what we see over here. Degrees of freedom 100. This is the chi-square value, 95.5, and this is the p value. So in this case, the p value is 0.6. So is this large or small? It's large. It's huge. It's not even close to 5%. Yeah. So if the p-value is smaller than 5%, then you would reject it all that they are independent. So here there's no statistical evidence that the two are not independent. Yeah. So if the two are, let's say, we can consider it as independent, then there's no relationship between the state and the area code. Said otherwise, the area code seems to be just randomly distributed over all the states. Yeah, so there's clearly something wrong with this area code. Okay, then this binning. So sometimes we want to reduce the number of values for an attribute which can contain a lot of values. And in this case, we have these day minutes, which I already alluded to some minutes ago. So over here we have these day minutes, and this relationship seems to be non-linear. So it could either be constant and then increasing, or first, let's say, decreasing and then increasing. So the idea is to bin the day minutes into low, medium, and high. Now let's have a look. So this is the idea of binning with respect to the dependent variable. If you recall, in last week we have looked at binning. We had 4 methods. One method was equal frequency in all the clauses. We could have this k-means, which was a data-dependent method, and we also had a method about clustering with respect to the dependent variable. And the dependent variable over here is churning. And in this case, we split in this case it's the evening minutes into 3 parts. And now we have to set the cutoff points of the classes, and in this case they say, well, 160 and 240, that seems to be nice numbers. Yeah, so the first is, let's say, 2 hours, and the last one is 3 hours. Yeah, this can be explained to the management. It's fictional. But if you want to do it, let's say, seriously, yeah, you could actually choose these numbers, these class limits, in a way to maximize the difference between the churning rates in these classes. So you can also optimize this in some sense. Now, let me see. So in this case, we are interested in the churning rate, so we should look at the relative frequencies normalized with respect to columns. In this case, we see that for the medium evening minutes, the churning rate is 14.1%, which is very close to the marginal probability, if you don't know any information. We see that it is somewhat lower for people who don't go frequently in the evenings, and it's somewhat higher for people who go somewhat more frequent in the evenings. Yeah, then we said, we have uncovered a significant difference, but yeah, the difference is really minor. Then over here, deriving a new variable. So these are flex variables. So over here we have the evening minutes, and I think this is the day minutes. And so what they did is over here they specified limits. Yeah, so everything above this line has a higher churn rate than everything below this line. So first we have to define this line, and this line is just specified by the constant and the slope coefficient. And then in this case, it seems that these people over here really do have a very high probability of churning, because they have a churn rate of 70%. Yeah, so this is really substantial, and I think almost 5 times as large as the, let's say, marginal probability. Then it's, as the text says, well, luckily there are only 200 customers, but this could be a quite substantial group. Sometimes we want to combine numerical variables, and then these variables, they live on a different scale. So if you want to combine two variables, we want these variables to live on the same scale. So what you can do is then normalize it, and in this case, you could take the z-scores. So the z-scores is just subtracting the sample mean and divide by the standard deviation. But then, in this case, we are interested in the customer service calls and the international calls. Then these standardized variables both have an average value of 0 and standard deviation of 1. Then you can combine them, and this is then the normalized histogram. And in this case, it seems that as the sum increases, or in this case, it's just the average of the two. If the average increases, also the churning rate increases. Then dealing with correlated variables. So, correlated variables should be avoided. That depends, of course, upon the level of the correlation. And it seems to be that LaRosse is really saying that variables are correlated if they are really, really highly correlated. Yeah? So in this case, we have 3 variables: day minutes, the day calls, and the day charts. And what we see is that day minutes, the day calls and day minutes are almost not related. The day calls and the day charts are almost also not related. But the day minutes and the day charts, they really lie on a straight line. Yeah. And if you do a regression, then actually you see that the day chart is a linear function of the day minutes, and we see an R squared of 100%. Yeah. So this is really perfect multicollinearity. And perfect multicollinearity is, of course, a problem, because then all kinds of estimates are not defined. So, and the idea is, of course, that the fee structure is something like the day charts, is something like a fixed fee plus a variable fee, which depends upon the day minutes. And here we see actually a linear relationship between the two variables. So this leads to perfect multicollinearity, and if you are perfectly collinear, then you can just forget one of the variables. You can just drop out one of 2. Yeah, so then one of the 2 variables should be eliminated. And if so this also of course happens for the evening charge, the night charge, and the international charge. Yeah, so that's just a fixed fee plus a variable fee depending on the minutes of calls in the evening, the night, or the international. So therefore, the number of attributes are then reduced from 20 to 40, and we will see later on that you can even reduce this further from 16 to a lower number of variables if you do principal controlling analysis. And so that's it in a nutshell. So you can use this exploratory data analysis to uncover some insights into the training data set without any specified model beforehand. Yeah, so we haven't referred to any theory, and so of course there should be theories about customer loyalty, etc. And also other theories in marketing. No, we haven't. We only looked at the data with an open mind, and we came up with some variables which really had an let's say explanatory power in bivariate sense. So if you consider two variables separately, and of course later on, if you're really modeling this churning rate, you should consider let's say multiple logistic regression model. Yeah. Any questions or remarks? Yeah.
Yeah, I was wondering if it's a bit more generic. I'm struggling. I understand a bit what we do in Python, and then I understand a bit on the slides. But then we have to combine.
Yeah.
And I start Googling because the book works with R as sort of the language of choice.
Yeah. Well, I actually on Canvas, I put this Jupyter notebook.
Yeah.
And in this Jupyter notebook, you have everything what's done in the slides.
Okay.
Over here. So this is the data frame. You can see all the columns over here, and then the extra from data analysis over here. It's just looking at the churn variable, the first 5. This is then the frequencies, so we can then sum them and make it into something over here. So this is the international plan. You see that 90% has this international plan, this 10% doesn't have this. And then here we see the tables. Yeah, so these are the first tables. As we see, and then we can standardize it. So these are the normalized cost tables. So that's over here. Yeah. Yeah, so all the things that were presented in the slides are also available in notebook form in Python. Yeah, so this is the first 2 files that we have considered. Yeah. Yeah, so good question. Other questions, remarks? Okay, let's take a break, and after the break we'll have a look at some of the questions at the end of the chapter.
Is your name? I saw one.
Yeah.
Same name.
What?
With a similar name.
True.
saw it somewhere. I don't know where, but the coach something came by. They also said this one, but it's in Slack, which is better sentence. VOLTT.
Zo hè?
Is it still working?
Yeah, but I don't think anyone is joining.
But it's also good that it's recorded.
I think great now. Well, you're not distracted by it.
So this is another brand.
Everything that's
So at some point in time, things
It doesn't work.
how would I know that you was the only one paying attention?
Really?
Because
Wow. Are you sure about that? I know.
Google.
hold on.
I mean, you know the stuff. You guys know the stuff. So. I was taking a couple notes.
Probably the same. If you write
Ik vind het. Nog eens some terrible news.
there is
Stanley just passed away.
95 of them, man.
then
Dude, that's old.
Sucks, man.
things we have connected to.
How many people make it 95?
Yeah, exactly. This is funny. They say if you run and pick up garbage, it's
But what
actually
was bad, I don't know if you read
healthier,
the
like,
articles
because it's more like
maybe a
kids,
month ago.
Yeah,
His
okay.
family was like already like
flocking. Actually funny.
trying to take apart like his
Now I have a target
People
my
are
run.
making,
It's
like,
actually
cash grab.
interesting. Run and pick up garbage instead of just stupid run.
like well towards his end people were like doing a cash grab like so a lot of people were like I don't know just trying to make money off of it. It's pretty bad.
Stanley.
Yeah. That's kind of shitty.
Hashtag sad. Hashtag sad.
Sad?
Yeah, someone died. Stanley from the Marvel movie. So, would you mind grabbing one of those sweet things there?
Yeah,
As long as no
I'm
one's
just so
looking.
much closer than you. But happy to.
These things, seriously, a box like this can feed a small African village.
It's, there is one
There are cashew snacks.
I started like
Sugar.
with a lot of sugar.
it would make sense.
Especially true.
I really saw coach somewhere for them.
Yeah.
I'm going to share your research.
Geen commentaar meer op de woordjes.
Nee, maar dat is zo ongezond dat ik het een beetje moet balanceren. Twee handen.
Are we still having dinner on the 1st of December? Are we still having dinner on the 1st of December?
Yeah, I'm good to that.
Huh?
I'm good to that. Will you be sending out the invite? Will you be sending out the invite?
I can. How are you? Should I ask how's the interview going?
I had two today.
Oh, okay.
One with Heineken and one with Uber.
And I'm likely going to be invited by Disney, which I'm really important.
Sounds great.
I mean, they're still need to hire more.
But honestly, I always say no. The first step, I think, is the most difficult one.
What, the first step?
Like being invited to interviews.
Well, I'm actually finding it that I do get invited quite often.
Well,
Huh.
because you're so good.
Because I'm so good. And I mean, I include a photo, and I wouldn't say there's a correlation there, but you know, there's also perhaps another correlation there. Just saying.
It can be the other way around. They saw you, they're like, let's invite him. Don't disappoint him again.
Look at that guy. Look at his face. Yeah, let's invite
The
him.
last one. I cannot eat this anymore.
No.
I would like to sign my name. You sign?
Oh, do we need to actually physically go there?
Ik heb geen club. Ja, Ajax denk ik. Kan die jongen ook niks doen? Ja, kwijt dan. Ja. Ja, ik was eigenlijk een goede vriend van mijn ja, weet je, zeker, maar vroeger was het ook een club wat past. Nu wisten we zo vaak van club. Ik bedoel, Ajax. Nee, dat is weet je, bij ons het slecht. Ja, do you think that banks will wel. Ik zag dat je een abonnement op korting heb jij ik vertel de helft. Kijk, ik doe even tuin. Ja, dat gaat gedaan denk ik. Nee, dan
Agora vestiu do Subami só. Eu continue passando mal.
Eu acredito que essa noite.
Ontem não
Ik zei nog wel eens spreken met mij.
Ja, ik zag bij jullie ook
US, here in the Netherlands. Where we always use it.
Middelbare wel wat Duits in de Tweede Wereldoorlog accent die Duits spraken. Gewoon zijn niet iedereen praat zo. Nou ja, daar wel ook steeds.
Yeah, so we have ING and Abiel. But it was
Ja,
Tony to have them. First of all these the solos. All these balances were sent to you. Now they are electronically, you have to pay for it.
Wat heb je tegen hem gezegd, Frank?
Ja, nou, moet je zelf denken.
Utrecht.
So what is
Serieus?
Nog een hoogzuiver voor die keer.
Ja. Oh, ik dacht dat iedereen die wel gewoon, er waren een aantal vragen die gewoon hetzelfde waren als de tentamen. Dus,
Ja, ik heb ook andere cijfertjes met hetzelfde.
Ja.
Oh,
Ja. Kan die wel hebben. Kan die wel.
Ja, daar was hij ook heel snel.
Deze gaat
Someone who using this card and not
We have to pay. So I think it
Jij was erbij.
Ja, weet je but that's
Ja,
that's that's all. At least.
gewoon, hè? Je moet al afgetekend.
Oh ja.
Because if you have this
No, I guess we didn't get to go.
Ik dacht dat het naar zijn oh, ik zie die al uit. Wij voor een nieuwe piek duidelijk heeft. Eerst echt een piek te maken.
Als je naar de translator.
Die zijn altijd heel aardig.
Simultaneous translator.
Waarom is het lezen? Oh, het is allemaal een beetje slag. Niet hem over 3 uur dan lukt. Dat is lang, hè?
I changed my signature because I used to sign in Chinese, and then nobody could copy for me. Hi. If I write in Chinese.
Yeah, but probably no one else. I think.
If I want you to copy for me.
You want her name or?
Because in China, I have a lot of bits. Crazy.
So,
Yeah, it does look like it.
I mean, if you do it,
between EDA and
I think it's also close.
guys. Explain the difference between EDA and hypothesis testing and why analysts may prefer EDA when doing data mining. So, yes, you have thoughts about this question?
If analysts don't have any priority, any hypothesis, you can start with EDA.
Yeah.
To identify the possible relationships.
Yeah, to identify possible relationships. So that's one reason. So if you don't have any particular model in mind before starting the analysis, then you could refer EDA as something else. Yeah, so to get to know data. Yeah, so there's also one way. So you, for example, want to identify outliers, because these outliers could heavily influence the testing procedure. Well, this is an MBA big data. So if you have big data, you normally think of huge number of predictors, number of predictors. So it could be that you just have, so over here we saw that we have 20 attributes, variables we could use as a feature, as a predictor. So in that sense, if you have a huge amount of variables which you could use, then this EDA is more open-minded. Yeah, so you just want to see whether some of the features really have predictive power or not. And that's without any reference to some theory. So let's see, how can we find the marginal distributions in the contingency table? That's an easy one. Over here. And everything. Yeah, you look at the margins of the contingency table, and so just the sum, the column sums, the row sums. And then you have to, of course, divide by the grand total. So what type of histogram is useful for examining a relationship between a numerical predictor and the target? Yeah, a normalized histogram. Yeah. But that's a normalized histogram because then you normalize the areas and you can really compare the areas between the bars. Let's have a look. Explain one benefit and one drawback of using a normalized histogram.
You can always take outliers.
What you can always?
It might always take outliers.
Yeah, but this has nothing to do with the normalized histogram. Yeah. So that's the example in which we had this churn probability of 100%, but they were only referring to 2 customers. So therefore, we should always, let's see, also look at the non-normalized histogram. And so one benefit is that you can easily compare. And of course, the drawback is then that you cannot see the absolute frequencies. Explain whether we should omit a predictor from the modeling stage if it doesn't show any relationship with the target variable in the EDA stage. So why shouldn't we omit predictor which is doesn't appear to have a relationship in the EDA stage? Yeah, so you could have these interaction effects. So it could be that there's no relationship between x1 and y, and there's no relationship between x2 and y independently. Yeah. But if you take the two together, then they could have a relationship with y.
So it's called detection guided optimization.
Explain the objective and the method of bidding based on predicted value. Yeah, well, it doesn't necessarily have to be more linear, but more clear in a sense. So, well, what we saw was this histogram, which was something like this over here, and then so it was a bit, let's say, non-linear. And then if you really compare, let's say, low, medium, and high, then you can see there's a declining, let's say, more constant and increasing relationship. So is this easy to do, bidding with respect to a predictive variable? So what's the problem? Yeah, the number of bins and how to choose the bin limits. Oh, it's already really quick. Only 10 minutes. So,
Already finished.
yeah. So, yeah, I think that in the previous year I spent somewhat more time into this Jupyter notebook, showing also the statements and comments with respect to all these graphs and tables. But I think you can also do it at home.
Let's do it now.
Best solution. Okay, so take it home and hope to see you all next week. So did everybody sign up the attendance list?
Heb ik weer wat gedaan?
Yes.
Ik heb er niks mee te maken.
You get a free laptop.
Yes, thank you.
Do we want to work here or go to